questions 1 through 4, I'm asking you to simplify the radicals. So for number 1, to begin simplifying, you need to start with your tree. You need to figure out what factors go into 63. And I know that 9 and 7, or 9 times 7, gives me 63. I can break down my 9 even farther to 3's. 3 times 3 gives me 9, and there's nothing really to break 7 down into, so I'm going to leave it. Now I need to find my pairs. And in this case, my pairs are a pair of 3s. So my 3 goes out front, and I'm left with this 7 over here. So that needs to go there. So my final answer then is 3 root 7 for number 1. Number 2 is asking me to simplify root 48. So I can just begin breaking this down. I like to start with even numbers. So 2 times 24, 2 times 12, 2 times 6, and 2 times 3. Now keep in mind for this one, you could have done 6 and 8. You could have done 3 and 16. Either way, you're going to get to the exact same answer. And so the next step I need to do is to circle my pairs. I have a pair of 2's and a pair of 2's here. Now when I have multiple pairs, I need to multiply my numbers together. So I have a 2 times 2 gives me 4, and I'm left with this 3 right here. So my final answer then is 4 root 3. Numbers 3 and 4 look a little crazy because we have numbers out front, but don't let that fool you. The first thing you should do, again, is to simplify. So the root of 32, 2 and 16, 2 and 8, 2 and 4, and 2 and 2. So I'm going to circle my pairs, circle my pairs. So again, I have a couple of pairs here. So 4 is going to go out front, and I'm left with this 2 here. But this is what I'm going to do here is this is what just the root of 32 breaks down to, but I still have this 4 out here. So I actually need to multiply that 4 to this as well. So this turns into 4 times 4, which is 16 times the root of 2. And then looking at number 4, 5 root 18, I need to break down my numbers. 18 is 2 and 9. All right, perfect. I have a 3 and a 2. But again, this only is for this, and I still have this 5 out here. So I need to multiply that. So 5 times 3 gives me 15 root 2. For problems 5, 6, 7, and 8 on your practice quiz for 10.1 to 10.2, I'm asking you to simplify the radicals, and number 5 and number 6 are pretty easy. There's no numbers out front. So for 5 and 6, you're just simply multiplying the two numbers that are under the root together and then simplifying if you can. So 7 times 6 gives me 42. And then I need to simplify if possible. The nice part is when you're given multiplication factors, you know that those automatically break down, or your number breaks down into the two numbers given because they multiply to it. So continue breaking down, can't break down my 7, my 3, and my 2, and now it can't go anywhere. I'm left with a 2, a 3, and a 7, and there's nothing there for me to combine. So actually, in this case, my final answer is the root of 42. Sometimes that happens. You get to breaking down into a tree, you have no pairs, can't do anything, so you go right back to your final answer. So let's look at number 6. Number 6 says root 10 times root 5. So no numbers out front. So I'm just going to simply multiply my two numbers. So 10 times 5 gives me 50. And I'm going to simplify again down into my factors. 5 doesn't break down anymore, but I do have a 10. So in this case, I do have a pair of 5s that go out front. And I'm left with this 2 here. So my final answer then is 5 root 2. Now looking at number 7, I have two roots being multiplied, but in this case, I also have a 2 out front. But don't let that fool you. You are still just going to multiply like terms, basically. So multiply your roots, multiply your numbers outside. I don't have a number here. 2 times what? In this case, we can assume that it's a 1 because anything times 1 just gives me itself. So 2 times 1 gives me 2. And then I'll use a different color here to kind of mark my roots. I have a 6 and a 3, so that's going to give me 2 root 18. Now I need to look at this 18 and know I can break it down. So I'm going to start with a 2 2 times 9 gives me 18, and break this down. So root 18 breaks down into 3 root 2 because I have pairs here. And then I have this 2 left over. But I still have this 2 out front that I need to multiply by. I had a 2 root 18. 18 broke down into 3 root 2, so I still need to multiply this 2 out front over here. So 2 times 3 gives me 6, and I'm still left with the root 2. So my final answer then for number 7 is 6 root 2. The same thing now for number 8. This time I do have numbers out front, and then I also have my roots. I'm going to start with my numbers out front. 4 times 7 gives me 28. 5 times 4 gives me 20. So 28 times the root of 20. Let me center that a little bit more for you. And now I need to break down this 20. So I have a 5 and a 4. I've got a pair of 2s. Then I'm done here with this 20. So I'm left with 2 root 5 for my root 20, but I still, again, have to multiply this out front. So 28 times 2 gives me 56 times this root of 5. All right, for problems 9, 10, 11, and 12, I'm asking you to rationalize and simplify. So remember, in math, we can't have these square roots. I have a root 3, a root 5, a root 4, and a root 10 in my denominator. That cannot happen. So we need to get rid of that radical in the denominator by multiplying both the top and the bottom by that root. So for example, in number 9, I need to multiply by root 3 to get rid of this, because in this case, it's being divided by root 3. To undo multiplication, to undo division, I multiply. So I need to do that. So then I just multiply straight across. Root 5 times root 3 gives me root 15. Root 3 times root 3 gives me the root of 9. But I can continue simplifying because I know the root of 9 is 3. The square root of 9, 3 times 3 gives me 9. So in this case, my final answer then is root 15 divided by 3. You'll notice a pattern. When you divide or when you multiply the denominators together, when you multiply a root times root of one number times the root of itself, root 3 times root 3, root 5 times root 5, root 4 times root 4, you just end up with that number in the bottom. So if you recognize that pattern, you can kind of eliminate a step, but I'll continue working through that. So number 10 says 10 divided by root 5. So to undo division, multiply by that root of 5, 10 root 5 times root 5 times root 5 gives me the square root of 25. I'm going to come down here to continue going. 10 divided by the square root of 25. The square root of 25 is 5. And then I can continue going. 10 divided by 5 gives me 2. So my final answer for number 10 is 2. Now numbers 11 and 12 have a number out front of your root, but don't let that fool you. You can still work through it. So I still need to get rid of this root 4 in the denominator. That's my biggest concern right now. So I need to undo that by multiplying. So I don't have a number out front, so it's 2 times 1, which is 2, times the root of 3 times 4 is 12. And then remember to undo that. That turns into the root of 16. So now I have 2 root 12 divided by the root of 16. The square root of 16, what number times itself gives me 16? That's 4. That's the same number right here. And then I can see that 2 and 4 can be reduced even more. So if I take a 2 out of both this 2 and this 4, I'm left with, oh, that should be a 12, sorry. Getting myself all confused here. So 2 root 12 divided by 4 reduces to 1 root 12, 1 times root 12 divided by 2. Or you can leave it as this, or you can continue simplifying to just the root of 12 divided by 2. We also have number 12 here the same way. I have this 6 out front. So I need to, but I still need to get rid of this root 10. So I'm going to multiply both here. So 6 times 1, because there's a 1 here, it's kind of assumed. 5 times 10 gives me 50. And then root 10 times root 10 is the square root of 100. I know the square root of 100 is 10, and I'm still left with this on top. And I have to keep going. I have 2 things that I can continue to simplify here. I have this 6 and 10, and I also have this root 50. This one's a pretty tricky one, so there's a lot of steps to it. I'm going to start with this root 50, though, and break it down. So root 50 breaks it down to 5 and 10, 5 and 2. So I'm left with 5 root 2. So I'm left with 6 times 5 root 2 on top, root 2, divided by 10. Continue going. 6 times 5 is 30 times the root of 2. And then I see this 30 divided by 10. 30 divided into 10 groups is 3 root 2. So like I said, we have 1, 2, 3, 4, 5, 6, 7 steps to simply rationalize and simplify this, but it breaks down to 3 root 2. For numbers 13, 14, 15, and 16, I'm asking you to find either the hypotenuse or the leg. So you're using the Pythagorean theorem, and we're also mixing in those radicals. So for number 13, I'm looking for the hypotenuse because I'm looking for the side directly across from my right angle. So I know that in this case, I'm looking for c squared. So I'm going to set it up as that. And then I have my 6 over here. So 6 squared plus my root 13 squared. And now I'm just going to continue solving. So I have 6 squared, or 6 times 6 gives me 36. Plus, and then remember what happens here with this root of 13 squared. This undoes itself. When you square a square root or square root a square, you're undoing it. So all you have left is this 13 equals c squared. I'm going to continue solving. 36 plus 13 gives me 49 equals c squared, but I'm not done because I don't need c squared, or in this case, x squared. I actually need just c. So in this case, I need to undo that square by square rooting both sides. And the square root of 49 is 7. So in this case, x, or my hypotenuse, is 7. Looking at number 14, I'm given a leg, I'm given 7. I'm looking for another leg because I'm given the hypotenuse, or this side directly across. So I'm going to set it up as 7 squared plus x squared equals 18 squared. Remember, your hypotenuse is always c. So 7 squared is 49 plus x squared equals, and let me grab my calculator for, I wish I could do 18 squared in my head, but 18 times 18 gives me 324. Now to get x squared by itself, I need to move this 49, and because it's positive here, I need to subtract it. So x squared equals 324 minus 49, which gives me 275. And then I need to find, again, because I'm not looking for x squared, I'm looking for just x, so I need to root both sides. So I need to find the square root of 275. And in this case, it gives me a crazy number. It gives me x equals 16 point, I'm going to call it 16.6. If you wanted to, though, you could do the tree. You could do a radical. So let's try that. 275. And I know that 5 goes into it because it ends in a 5. So I'm left with 5 and 55, 5 and 11. So 5 times 11. Or it could be 5 root 11. Number 15 is asking me to find, I'm given a leg and a leg here, and I'm looking for the hypotenuse. So again, set it up just like 13 4 squared plus root 13 squared equals c squared. And then so I'm left with 4 squared, which is 16, 4 times 4. Remember, when we square a square root, it undoes it, so we're left with 13. And I'm going to continue solving. I have I have 16 plus 13 gives me 29 equals c squared. Gotta undo it because I need just c. And in this case, I can't break down 29 anymore. It's an odd number. So in this case, the square root of 29 is c. Now I'm going to come over here to number 16. I'm going to grab a different color. I'll solve this one in black here. So again, I'm looking for a hypotenuse, so I need to set up my Pythagorean theorem. So root 7 squared plus root 3 squared equals c squared. This undoes itself. This undoes itself. So I'm left with 7 plus 3 equals c squared. 7 plus 3 gives me 10. And then I need to break that down because I'm looking for just c. So in this case, the square or the hypotenuse in number 16 is root 10. For problems 17 through 20, it says solve for the missing hypotenuse or leg, assuming that these are 45, 45, 90 triangles. So remember, 45, 45, 90 triangles are a specific type of isosceles triangle, meaning they have two legs that are congruent to each other, as well as two angles, the base angles we call them, that are congruent to each other. And the relationship then between the legs is that the legs are congruent to each other. So I'm going to do x equals or is congruent to x. And then the hypotenuse, I'm going to put hype over here for hypotenuse, is equal to a leg times root 2. So for example, for number 17, I'm given a leg of 10. I'm looking for the other leg, and then I know my hypotenuse is 10 root 2 because my hypotenuse is equal to a leg times root 2. That also means that for x, I'm looking for the other leg. If I know one leg is 10, this one also has to be 10. Then for number 18, it says what would be the length of a leg if the hypotenuse or BC is 10? Now here's where things get a little tricky because we're used to seeing that root 2 after the number. And in this case, we don't. But because I know that the hypotenuse equals, and I'm going to do x for leg. I'm going to call my legs over here x, is equal to a leg times root 2. In order to get a leg by itself, I need to divide by this root 2 to get that leg by itself. So I know that my hypotenuse is 10 equals x, or a leg, times root 2. And then because this is multiplied, I need to undo that to get x by itself. So I need to divide both sides by root 2. But remember, we cannot have radicals in our denominator. So I actually need to do 10 root 2 divided by root 2 times root 2 over root 2 and continue solving. So my top is 10 root 2 divided by the root of 2 times the root of 2 gives me the root of 4. And I know the square root of 4 is 2. Or remember, when you take a square root times the same square root, you just get the number left under the root. And I can continue simplifying. I have this 10 and 2 out front here. So 10 divided by 2 gives me 5 root 2. So I know that a leg is 5 root 2. Looking at number 19 now, again, we have the same thing. We have a whole number here in our hypotenuse. So I need to set it up. I'm going to use a different color here to keep things straight. So I know that my hypotenuse is 16, and that equals a leg times root 2. So again, got to divide by that root 2, but I can't have that radical down there. So I end up having to multiply by this root 2. So I'm going to keep going here. So my top is going to be 16 root 2 divided by 2. And then I know that I can divide 16 and 2. 16 divided by 2 gives me 8 root 2. Now, if you notice a pattern here with numbers that are even numbers in your hypotenuse, I'll give you a quick tip. This only works if your hypotenuse is in even numbers, so numbers that are divisible by 2. You divide it by 2 and add a root 2 for the leg. So for example, number 18, you figured out that if the hypotenuse is 10, a leg is 5 root 2. 5 is half of 10, and then you just add a root 2. 16 divided by 2 gives me 8, and then we have this root 2 here. So again, only if your hypotenuse is an even whole number can you kind of follow that trick. Divide it by 2, add a root 2 to figure out the leg. So number 20 then, what would be the length of the hypotenuse if AB, or a leg, is 7? I'm going to use green for this one. So I know that a leg is 7, and I also know then that this is 7. And if my hypotenuse is equal to a leg times root 2, then my hypotenuse is going to be equal to a leg, which is root 7 times root 2. Let me finish up that time symbol there. So my hypotenuse, I'm going to start with H, is 7 times 2 gives me 14. And then if I can simplify, I will. 2 and 7, and I can't go anywhere, so that means my final answer is root of 14.